In the past 20 years, the concept of autonomous driving has advanced significantly, partly because of the quick advancements in radar technology and CPU power. Since ultralight hardware can now make decisions based on self-improving algorithms thanks to portable technology advancements, autonomous vehicle developers have a better chance of simulating the real-time decision-making of people. The development of autonomous vehicles dates back to the middle of the 20th century. In 1961, James Adams, a Stanford engineering student, created the first completely autonomous lunar rover. In the years that followed, private companies created further autonomous vehicles and unmanned aircraft, but the technology remained specialized until Tesla introduced Autopilot in its Model S sedan in 2015. Autopilot was the first advanced autonomous technology to be made available to mass-market consumers, and it was designed to help drivers navigate roads, exits, and stop-and-go traffic with the least amount of driver input. The forward-facing cameras and radar systems used by today's autonomous vehicles gather pertinent data on the state of the road for later analysis. These systems can identify, categorize, and weigh road obstructions, providing the vehicle's processors with the knowledge they need to select the least difficult route. These weights have values that reflect how catastrophic an impact on a certain object would be. Importantly, each weight is subjective, and the developer's individual opinions have a significant impact on how an autonomous car would behave. The Society of Automotive Engineers, SAE International, created 6 levels for autonomous cars, with level 0 denoting complete lack of automation and level 5 denoting full autonomy, requiring just the entry of a destination to keep up with the rapidly developing field of autonomy. Level 3 autonomous vehicles like an Audi A8 luxury saloon equipped with the traffic jam pilot are supposedly available, but several nations, including the UK and the USA, are still awaiting legislative authorization. Tesla's Autopilot roughly equates to level 2 automation. Although level 4 and level 5 autonomous vehicles are not yet widely accessible, automobile manufacturers like Tesla and Audi, as well as technology firms like Uber, Lyft, and Google's Waymo, are vying for full autonomy. The history of autonomous vehicles and their technological condition. USA. Regulating autonomy is difficult because of how quickly it has grown. The Safely Ensuring Lives Future Deployment and Research in Vehicle Evolution, Self-Driving Act, a proposed piece of legislation that aims, among other things, to transfer authority for autonomous vehicle testing from American states to the federal government, was first brought up for discussion in the U.S. Congress in 2017. Additionally, the Self-Drive Act would give the National Highway Traffic Safety Administration, NHTSA, complete responsibility for the design and development of autonomous vehicles and obligate the agency to put up a set of autonomous safety regulations within 2 years. Importantly, the law would require autonomous car producers to create a privacy plan that outlines all possible applications for passenger data. The Self-Drive Act increases the NHTSA's yearly authorization limit for autonomous vehicle testing from 2,500 to 100,000 vehicles after 4 years. As of June 2018, the measure still requires Senate approval because it has only been approved by the House of Representatives. States have enacted, or are working on implementing, their laws governing the testing and operation of autonomous vehicles, notwithstanding the absence of agreement in the U.S. Congress. For instance, California began reviewing requests for testing permits for autonomous vehicles with up to level 4 autonomy in April 2018. According to the California Department of Motor Vehicles, CADMV, an autonomous vehicle must be able to withstand cyber attacks, be restricted to certain areas of a city, and have some means of two-way communication to be eligible for a permit. Arizona's Governor Doug Ducey signed an executive order setting the criteria for testing and using autonomous vehicles on public highways in March 2018. Some of these prerequisites are that the vehicle's automated driving system complies with applicable federal law and motor vehicle safety standards, that the vehicle will reach a minimal risk condition if the automated driving system fails, that the vehicle complies with all applicable traffic and safety laws and regulations of Arizona, and that the vehicle satisfies all applicable certificate, title registration, licensing, and insurance requirements. Union of Europe. Due to its significant automotive industry, Germany has been a leader in the European Union (EU) when it comes to autonomous car policy. Germany has a law in existence as of 2017 that, under certain circumstances, permits the testing and use of autonomous vehicles on public roads. One of them is having a safety driver behind the wheel who can take control of the vehicle if necessary. In 2019, the law will be updated to reflect technological advancements. The new law creates a more robust testing ecosystem within German borders, but does not legalize level 5 fully autonomous vehicles. To guarantee that the UK remains one of the greatest places in the world to develop, test, and drive self-driving vehicles, the government in the UK stated in March 2018 that it had commissioned a review of driving legislation. A 3-year assessment of current driving laws will be conducted by the Law Commissions of England and Wales and Scotland to identify any legal barriers to the widespread adoption of self-driving vehicles and highlight the need for regulatory reforms. Who is the driver or responsible party? How to assign civil and criminal responsibility where there is some shared control in a human-machine interface. The role of automated vehicles within public transport networks and emerging platforms for on-demand passenger transport, car sharing, and new business models providing mobility as a service. Whether there is a need for new criminal offenses to deal with these issues will be some of the issues that will be examined as part of the review. Emirate of the Arabs. With the overall goal of converting 25% of Dubai's total transportation to autonomous mode by 2030, the Dubai Future Foundation and Dubai's Roads and Transport Authority established the Dubai Autonomous Transportation Strategy in the United Arab Emirates in March 2018. The strategy will entail, among other things, the creation of specialized infrastructures for the new technologies, as well as the formulation of particular regulations for the growth of autonomous mobility. Japan. The National Police Agency of Japan, which recently established an expert panel to discuss and propose rules for autonomous vehicles, including in terms of penalties for accidents and traffic law violations involving Level 3 and Level 4 autonomous vehicles, has established guidelines for testing automated vehicles on public roads in Japan. Additionally, by 2019, specific legislation is expected to be introduced to the nation's legislative body. Australia. Australia's government intends to regulate autonomous vehicles uniformly, and national law in this area is expected to be implemented by 2020. Several recommendations are made for this legislative reform in a policy paper released by the National Transport Commission in May 2018 to provide clarity about the situations when an automated driving system, ADAS, rather than a human driver, may drive a vehicle. Ensure there is a legal entity that can be held accountable for the operation of the automated driving system. Establish any new legal obligations that may be required for users of automated vehicles. Consequences for human rights, ethics, and liability. Our legal and societal links to regular transportation could change as a result of the novelty of autonomous technology. Importantly, since there is no human driver in the driver's seat, autonomous vehicles present issues of accountability for driving behavior. It is uncertain how the legal system would define negligence if an autonomous vehicle were to be held accountable for a tragic collision, for instance. Furthermore, it is also unclear whether and how a company's executives, marketing staff, and software and hardware developers would be held accountable. How the technology will handle life or death decisions is a key discussion topic about the future of autonomy. Imagine a situation where a young child runs out into the street in front of a self-driving automobile. The choice is whether to veer away from the youngster, endangering the safety of the other passengers, or to keep going, running the risk of running over and hurting the child. Some observers contend that rather than debating who dies in these instances, the conversation should center on how businesses can prevent no-way-out scenarios from ever occurring. While there will always be edge circumstances, in which case there should be a clear mechanism for transferring responsibility to the relevant parties, businesses should focus more resources on advancing the technology so that life or death situations only occur in very rare instances. For self-driving cars, the difficulty in simulating human judgment in all driving situations continues to be a major challenge. Do you like it? Kindly give your valuable response in our comment section below, and don't forget to subscribe to our YouTube channel for more interesting and informative videos.